Good day everyone. Good day ma'am. My name is BLESSY ATIS Ilajas from BSEE 1A, and this is my work and explanation on what I have understand from the book. So given na ang solution sa problem set, dayon ang ako lang is gi-explain kung giunsa siya pagkuha. So problem set number 5, number 1, example 12.7 on page 606. Compressive stress in a pillar. A sculpture weighing 10,000 Newton rests on a horizontal surface at the top of a 6.0 meter tall vertical pillar, figure 12.19. The pillar's cross-sectional area is 0.20 meter squared and it is made of granite with a mass density of 2,700 kg per meter cube. Find the compressive stress at the cross-section located 3.0 meter below the top of the pillar and the value of the compressive strain at the top 3.0 meter segment of the pillar. So, the given. So, sculpture weight is equals to 10,000 Newton or 1.0 times 10 raised to the 4th power Newton. The height of pillar is equals to 6.0 meter. Pillar's cross-sectional area is equals to 0.20 meter squared. Density of granite P is equals to 2,700 kg per meter cube or 2.7 times 10 raised to the 3 power kilogram per meter cube. So A is equals to H is equals to 3 meter. A is equals to 0.20 meter squared. P is equals to 2.7 times 10 raised to the 3rd power kilogram per meter cube, and then the G, which is, or the gravity, is equals to 9.8 meter per second squared. So to find the compressive stress, so ang compressive stress lang gipangita, need na to siya pangitaon ang weight of the pillar. So ang pagpangita sa weight of the pillar, we must need first its value and the mass, ang iyang mass. So to solve the volume of the pillar, ato i-multiply ang cross-sectional area, which is ang 0.20 meter squared, dayon ang height dayon niya, which is 3.0 meter kana siya, dayon so i-simplify i-distribute, so i-simplify, so 0.20 meter cube squared times 3.0 meter is equals to the velocity of 0.60 meter cube. Dayon, then ang pagpangita na sad sa mass of the pillar, need na to siya i-multiply sa density of the granite. So simply M is equals to PV is equals to, ang atong P is 2.7 times 10 raised to the 3rd power kilogram kilogram per meter cube. Kani siya, dayon ang atong V, kani velocity nakita naman, so ato siya i-distribute 0.60 meter cube. So i-simplify dayon, so we must get the mass is 1.60 times 10 raised to the 3rd power kilogram. And to know the weight of the pillar, we must use this formula in which mass of the pillar is equals to mass times gravity. Dayon na siya. So simply distribute, so ang mass na to kanina man, so nakita na tong mass, so i-distribute lang. Then ang atong gravity is 9.8, kani siya 9.8 meter per second squared. Dayon simplify dayon, then we can now arrive the weight of the pillar, in which 1.568 times 10 raised to the 4th power Newton. So since we already know the weight of the pillar, to solve the stress, we need to find first the normal force that acts on the cross-sectional located 3 meter below the sculpture. To find for the force, i-add na to ang WP and WS. So kanang since nakita naman nato ang ilang value, so ato siyang i-distribute, then we can now get the answer. So na i-distribute na nato, so nakuha naman nato ang kuan WP kana siya, then ato din siya i-distribute. So we can now get the answer, in which 568 times 10 raised to the 4th power Newton. So ang formula para makita ang stress is equals to the normal force that acts over the cross sectional area. So distribute 2x, then simplify. So i-divide na siya, divide, then 2.568 times raised 10 to the 4th power Newton over 0.20 meter cube. So now we can get the answer, derive the answer of 1.284 times 10 raised to the 5th power pascals, or 128.4 K pascal. So dito sa B. So after getting the value of compressive stress, after getting the value, so then pangitaon na pud nato ang compressive strain, in which the formula is stress over Y. So ang kaning Y is kuan siya, Y is the modulus of granite, which is 4.5 times 10 squared K pascal. So ano siya, ang stress nato is kaniman 128. So ato na siya i-distribute, then ang atong Y is equals to 4.5 times 10 squared K pascal. So ikuha na lang yun. So i-simplify lang dayon. So i-divide, so we can now get the strain, which is equals to 2.8 times 10 raised to the negative 6th power. So ano siya. So now let's proceed to the next example, 12.8 on page 608. Stretching a rod. A 2.0 meter long steel rod has a cross-sectional area of 0.30 centimeters squared. The rod is a part of a vertical support that holds a heavy 550 kilogram platform that hangs attached to the rod's lower end. Ignoring the weight of the rod, what is the tensile stress in the rod and the elongation of the rod under the stress? So from the problem, so these are the given. So the original length is equals to 2.0 meter. Then ang atong mass is 550 kilogram. Then ang atong cross-sectional area is equals to 0.30 centimeter squared, or 3.0 times 10 raised to the negative 5 power meter squared. Then ang atong Y is equals to 2.0 times 10 raised to 11 power pascal. So solution, letter A. So first, we need to find the tensile stress. To solve the tensile stress, we need to use this formula. Kani ato ning gamiton nga formula, forming force over cross-sectional area. Then distribute dayon ang atong kuan, i-distribute dayon. So then atong kuan, then A is equal kani 3.0 times 10 raised to the negative 5 power meter squared. So simplify dayon, so we can now get the tensile stress is equals to 1.8 times 10 raised to the 8 power pascal. So that's the final answer. So next, the elongation of the rod under the stress. So para ma-solve ang elongation of the rod under the stress using its original length, which is 2.0 meter. 2.0 meter. Dayon. And then we're going to invert this equation. Kani i-invert natong this equation. So kani i-invert natong equation. So mauni ang equation ato gamiton to find the elongation of the rod under the stress. Since naa naman ang value anhi, kanina naman ang value anhi, so we're just going to plot the other values, which is our original length is equals to 2 meter, and the y or the modulus of the tensile, which is 2.0 meter over 2.0 times 10 raised to 11 power Pascal. So, ikuan na siya, i-multiply, then i-simplify, then we can now arrive this answer. 1.8 times 10 raised to the negative 3 power meter, or 1.8 millimeters. So, this is the elongation of the rod under the stress. So let's proceed to the problem set number 3, example 12.9 on page 611, hydraulic press. In a hydraulic press, figure 12.23, a 250-liter volume of oil is subjected to a 2,300 psi pressure increase. If the compressibility of oil is 2.0 times 10 raised to the negative 5 power per atmosphere, find the bulk strain and the absolute decrease in the volume of oil when the press is operating. So, the given is volume is equals to 250 liter, and the change of P is equals to 2,300 psi, or the pressure increase. Then K is equals to 2.0 times 10 raised to the negative 5 power over per atmosphere. So then ang kuan dayon ang gipangita din is kulang the bulk strain and the absolute decrease in the volume of oil when the press is operating. So to find the bulk strain, we need to convert the pressure increase from the PSI atmosphere. So, i-divide lang nato. So, kani siya ang 14.7 atmosphere. So, this is equals to 160 atmosphere. So, muna siya ang atmosphere increase. So, to solve the bulk strain, we must use this equation kani. The change of volume relative to the original volume. Pero, we could not use it. So, dili nato siya maggamiton. Instead, kani nga equation, 12.40. But then, we have to invert this equation because we have the compressibility of here, which is compressibility describe the change in the volume of fluid per unit increase in pressure. So, since we have the compressibility value and our pressure increase value, so we multiply it. So, ato siya i-times 2.0 times 10 raised to the negative 5 power per atmosphere times 160 atmosphere. So, simplify. So, the bulk strain is equals to 0.0032. And then, to know the absolute decrease in the volume of oil when the press is operating, we just have to multiply it with the original volume. So, ato siya i-times sa original volume in which kuan ang bulk strain is 0.0032. Then ang original volume dayon niya is 250 liter. And this would be the decrease in the volume of oil when the press is operating, in which is equals to 0.78 liter. So, nabantayan nato nga ang working press is operating, in which is equals to 0.78. So, nabantayan nato nga ang working working substance in hydraulic press of the problem were changed to water, then the bulk strain and the volume change will be 2.32 times larger. So, kuan siya, dako siya. Sumata siya. So, let's proceed to the next problem set, number 4. Example 12.10 on page 612. An old bookshelf. A cleaning person tries to move a heavy old bookstore on a carpeted floor by pushing tangentially on the surface of the very top shelf. However, the only noticeable effect of this effort is similar to that seen in figure 12 on 12.24, and it disappears when the person stops pushing. The bookcase is 180.0 cm tall and 90.0 cm wide, with four 30.0 cm deep shelves, all partially loaded with books. The total weight of the bookcase and book is 600.0 Newton. If the person gives the top shelf a 50.80 Newton, 50.0 Newton push that displaces the top shelf horizontally by 15.0 cm relative to the motionless bottom shelf. Find the shear modulus of the bookcase. So the given, we need to identify what are the given in the problem. So we have tangential force is equals to 50.0 Newton, and then the displacement, which is 15.0 centimeter, and the transverse distance 180.0 centimeter. Then ang area, which is 2700.0 centimeter squared. So where we get from this 90.0 centimeter wide, then multiply by 30.0 centimeter deep shelves. So our task is to find the shear modulus of the bookcase. So solution. So we could notice that only the significant information due the physical dimensions of the bookcase, its value of the tangential force, and the displacement. Then we could use the formula to find the shear modulus, which is shear stress over shear strain is equals to tangential force over the area multiplied by the transverse distance and the displacement. So plotting the values, we could get this answer. So kanin siya i-plot nito. So ang atong kanin is 50.0 Newton, then ang atong area kana siya to distribute na, then we can get this answer: 20/9 times 10 raised to the third power pascals, or 2.222 k pascals. So shear modulus, also the proportionally constant of stress, as is defined by the ratio of the shear stress and shear strain. Then we could also find the shear strain and shear stress, which is gamiton nato ni siya nga equation. Kani siya. So tangential force over the area, then simplify dayon, then we can get this answer: 185.2 pascals. And for the displacement, and for the displacement over the transverse distance would be 0.083. So the shear stress is due to the forces that act to the panel, to the surface, and the shear strain is caused by the shear stress. And the last problem set number 5, example 15.2 on page 751, determining the equations of motions for a block and a spring. A 2.00 kilogram block is placed on a frictionless surface. A spring with a force constant of K is equals to 32.00 Newton per meter is attached to the block, and the opposite end of the spring is attached to the wall. The spring can be compressed or extended. The equilibrium position is marked as X is equals to 0.00 meter. Work is done on the block. Pulling it out to X is equals to positive 0.02 meter. The block is released from rest and oscillates between X is equals to positive 0.02 meter and X is equals to negative 0.02 meter. The period of the motion is 1.57 seconds. Determine the equations of motion. So these are the given. So the amplitude is equals to positive 0.02 meter. Time is equals to 1.57 seconds, and the phi is 0.00 rad. So in order to find the equation, need to pangitaon ang angular frequency first. So ang angular frequency is equals to 2 pi over ang time niya, in which 1.57 seconds. So in which maka-derive siya answer of 4.00 second raised to the negative 1 power. So next, to get the maximum velocity, which is equals to amplitude multiplied by the angular frequency. So our amplitude is 0.02 meter multiplied by the angular frequency which is equals to 0.08 meter per second. Then ang atong maximum velocity. So kano siya? Maximum velocity. So after proceed sa maximum acceleration, which is the amplitude of the motion times the angular frequency squared. So 0.02 meter times 4.00 squared raised to the 1 power squared, in which ang atong maximum acceleration is equal to 0.32 meter per second squared. Then after getting all of that, the next step is to fill the equation of motion. So first, the equation of position as the function of time, which is equals to a cos so wt plus v. So angular frequency plus and time. So next, velocity of the mass oscillating on simple harmonic motion. So harmonic motion, which we could taking the derivative of the quotient equation. So so negative 0.08 meter per second sine 4.00 square s raised to the negative 1 power. Katugo naman ko, sorry. So so ang last one is the acceleration of mass on spring can be found by taking the time of the velocity. So maod dayon ni siya mahimo ang negative maximum acceleration. So negative 0.32 meter per second squared. Dayon, then ang cosine o ang angular frequency plus v din plot. So i-plot din ang values. So mana siya. So kana siya ang mga equations sa motion. So ano siya. That would be all. Thank you. Natog na ko.